My.
Okay, here we go. All right, there we go. Welcome, everybody, to another episode of our Labs Open Office Hour. This week, we're joined by Dr. Don Kinghorn, our scientific computing advisor, an all-around cool guy. I love listening to everything you have to say, Don. It's very infectious. But
I always enjoy you. I always enjoyed
oh,
BSing with you, Houston.
thank you. But just in case anybody doesn't know, and the folk who may be listening to this later or watching, give us a little background about who you are and what you do for Puget.
Okay. Yeah, I'm the scientific computing advisor, and that means stuff, any sciencey stuff, right?
Mm-hmm.
Um, and including what I spent a lot of time with is machine learning, AI, all that really nice stuff. My background is a PhD in theoretical chemistry from way back. Was a researcher for a long time, and then mainly kind of migrated into high performance computing for a long time, and then well, all of these things kind of go along with a long time.
Sure.
But now I'm at Puget Systems and really having fun with that. It's great because uh, the thing that gets me up in the morning, the thing that drives me forward is just helping people out with problems and stuff they're trying to work on.
Yeah.
So, and I get to do that. So
It's gotta be a lot of fun too, because like it kind of exposes you to such a broad range of different topics and problems to solve. Like,
oh man, yeah, oh yeah, totally. Yeah, it's always fresh.
That's
Plus, I'm a hardware junkie. So
yeah,
I mean, that was kind of my motivation in the first place. Back quite a while back now, actually.
Yeah.
It was like, ooh, hey, there was new hardware coming out. I was like, ooh, I really want to get my hands on that because I hadn't done that kind of stuff for a while. And it's like, oh yeah. It's like, let's do that. It's like, yeah, okay.
That's cool. Which actually brings us right to the big topic for this week. You've been working on getting 4 RTX 3090s in one system on one power supply, a 1600 watt, our biggest one that we sell. And when you first suggested this idea, it was something I had never heard of. That you could actually manipulate the power draw of the video card. And I'd kind of heard about some of that kind of thing, like in the overclocking space and stuff where you could undervolt use CPUs and GPUs and things. But this is a little different, right?
Yeah.
So let's get a little talk about that. Like, I guess first off, how did you even know that you could do this?
Oh, well, okay. First of all, I was not going to be stopped from doing because when the 3090 came out and I tested that thing, first fired up some TensorFlow benchmarks with that. It was like, oh my God, this is a great card. And it was like, everybody's going to want to do 4 of these in a box.
Right.
Because I mean, it was like, yeah, that's what you want. You want to be able to fire up this thing to the max, but then, man, running at these things, hitting a 350 watt TDP on the GPUs that's a lot of power getting sucked down. It's like, oh, big problem. It's still a problem. But it's like, okay, yeah, we've got to solve that. But then it was fairly obvious to me that, yeah, we can probably do this. I was just, my expectations of success were a little bit low.
Okay.
But the NVIDIA, their system management interface. Okay, there's 2. There's the NVML or something like that. Their management layer. This is a programmatic management interface, and then there's the command line tool that interfaces to all that, which is NVIDIA SMI, the system management interface. And when you install the Windows driver or the Windows driver. This applies to Windows too. Okay,
Okay.
but when you install the NVIDIA driver, NVIDIA SMI is installed. Okay, and that is a really powerful tool, and you can control a lot of aspects of the GPU. You can use it for monitoring. It gives you all the information about the card.
Mhm.
In fact, monitoring tools, little commercial things or little applications, they usually call this interface in the back end.
Oh, okay.
But yeah, it's a really powerful tool, and I use it all the time when I'm working with NVIDIA GPUs, even just to monitor the performance load. How are the GPU? Am I getting 100%? Are these things hitting 100% of
Oh,
load? And stuff like that. So I use it all the time, but it's really a capable tool. And you can get in there and change parameters for the card.
okay.
Okay, so you can do this in live while the thing is up and running. And there's stuff in there for managing the heavyweight cards, like the A100, the server compute stuff and all that.
Right.
Um, so it's easy in there to actually set the power limit.
Wow.
Those are parameters that you can control with just a single command with NVIDIA SMI. So you
Wow.
can set you can set the minimum and maximum power.
Mhm.
You can set almost anything you can think of to control on the GPU. You can do. I mean, a
Wow.
large amount of it.
Cool.
But yeah, you can set power limit, no problem. So you can set a cap on what it can draw.
Sure.
Um, the especially, but the consumer cards are a little bit funny sometimes because they have these boost clocks
Oh, sure.
and all kinds of crazy things going on in there. Um, but this does what it says. I mean, this works. And but the thing that really, when I was thinking about this, I was going, oh man, okay, we have to limit the power usage on these GPUs in order, because really, this is something I've talked with John about for years. It's like, okay, when we're designing a system for really heavy compute, we have a limit, we have a constraint.
Sure. Yeah.
Um, Really, a workstation that we're going to do as a product needs to be within the constraints of being able to run on a single, and I usually specify it as a single US 110 volt 20 amp power line
Right.
as being
Just
kind of a limit for how much power you can draw, how much compute you can get, because your compute's limited by the amount of power you put into it.
okay.
At the end of the day, that's kind of what it comes down to. But a more realistic limit is a US 110 residential 15 amp line.
Okay.
That's the common kind of line that you're going to have in a wall outlet or something like that in
Like
your
at a
house.
science lab or high school or something,
Yeah,
or at home
they'll
even.
probably have anything that's industrial or academic or anything like that will probably have beefier lines just as default.
Okay.
So that's why usually I say, yeah, 20 amp is kind of something that you can probably expect. And most universities and stuff like that, the will have people that will come out and run power lines for you, whatever you need.
Oh, okay.
If you you need extra stuff, you need a 240 volt that can rock a little cluster or something like that. Um, but yeah, so we need that restriction. So really need to get this thing down to where like the total draw on the system is not any worse than like running a hair dryer.
Oh, sure. Okay.
Okay.
Yeah. Yeah.
And that turned out to be pretty easy to do and still get great performance. So
Yeah.
really happy about that. But I think maybe should we just go ahead and bu-
Yeah, I was
I'm
just
going to
about
go
to
through
ask.
the post that I put up
Sure.
last Friday,
Okay.
and yeah, let's go ahead and look at that.
Okay.
And I have to peek around because I have this sitting on a monitor that's behind my main monitor. uh, but yeah, I just had to get the mouse over there. Okay, let's see that. Oh man, can
Oh,
I?
and just in case anybody would like to follow along, I'm post the link in the chat.
Let's see. This is Edge here. Okay, good. That works. Okay. I bumped that. Wrong one. There we go. I got a little kitty cat sitting here wants to sit on my mouse. Okay, this is the post. This went up last Friday on the HPC blog at PewDid here. And there. Oh, will it scroll? Oh man, I gotta get. Oh, there we are. Okay,
There we go.
I gotta remember where the mouse is. Anyway, okay, that was I gave it this kind of funny title here: Quad RTX 3090 GPU, wattage limited, max Q, right? The thing that inspired me to do this, it was like because if you look at a lot of laptops, they'll tout this as a feature. They'll say, okay, with max Q, NVIDIA max Q, and it's like, oh, what the heck is that? And what it really is, and they did a serious effort on doing this, but their engineers, they looked at performance of a GPU and a laptop, and they did power restriction. They did power limiting on the GPUs to accommodate all of the parameters that they need to have in a laptop. So they had to be able to get good cooling. They had to coordinate this kind of like with a CPU load. And but what they wanted to try was like, okay, what's the best performance when you increase the power into into a GPU, the performance goes up.
Sure.
Okay. But it doesn't go, it starts off pretty linear. It's going like straight up, but then it rolls off. And by the time you get up closer to the maximum performance for the card, you can start getting up to its power limit, then the performance gains are very small. So it's like, okay, where's that kind of spot where you can find like a really good performance? It's basically the best performance efficiency for the device. So, and they call it max Q. It has something to do with pressure and rocket launches and stuff like that, right?
Okay.
So it's an abuse. It sounds cool. It sounds cool. I like it, and it's kind of appropriate. I mean, in a way, in a serious way, really. But anyway, so that was the max Q thing. That was my inspiration. It's like,
sure,
yeah, heck, man, I'm going to put 4 of these puppies in a box, and I'm going to find basically a max Q, however I define that,
sure,
at the performance threshold that I'm willing to live with, and at a reasonable power level. So that was the idea. And yeah, I did this just in one of our test beds. So this was open air. This was with the gigabyte blower card. This is like,
so just hang on just a moment, just to clarify. So this is, you say open air, this is like one of our test benches. This isn't stuffed into a Fractal XL.
No.
Okay.
No.
But
Yeah,
potentially that's what it would be in.
Yes. Yeah. But this is a consideration for anybody that wants to do that, because no matter what, it's still a lot of heat being generated.
Right.
Okay. So you have to get that away from the GPUs, away from the system. And pretty much, and you have to be able to physically get them into the box. And so the only thing that we basically have right now that we could use is this gigabyte blower card. Okay, and so that's got Gigabyte makes these really nice cards for stuff like this. And they do it. You know,
Yeah.
they step up to the plate and actually do this. Those things are 2U, or well, not 2U,
Yeah.
two
Two slot.
slot,
Hmm.
two slots. So you can get four of them in a system that will support four GPUs, and they have good blowers on them. So they're taking air in from near the rear of the card and blowing it out the back of the case, blowing it outside of the case. So very good. However, the GPUs are really packed right next to each other. They're
Hmm.
in there,
Yeah. There's
and
nothing between them.
yeah, there's nothing. I mean, they're touching. Um, so yeah, successful system has to have really good heat exhaust and heat flow through the chassis in order to keep, to lower the pressure going in these fans, so all the heat can get exhausted out and just keep everything in there cool.
Right.
Um, so we haven't looked at that. We didn't get the IR thermal camera out and
Right.
do heat imaging or anything like that. We haven't put this in a closed case or anything like that. This was just a matter of, okay, will this work? Can we do this? That was the main thing I wanted to know. Whether we do it or not as like a product, something that we offer, if we offer a quad, um, we may or may not do that, and we probably won't do it unless we can get the cards firmware modified to
Right.
limit power, so that it's not subject that so that you don't have to do this at with with tools, with control tools, that are loaded in the OS at boot time.
Mhm.
Um, so yeah, so this is still open, but this is really cool, and I've already gotten great feedback from people, and I knew it. I mean, when I first saw that, I mean, I knew that all these researchers around are going to go, oh man, I want to do four of these things. How can I do this?
Right.
And so that was this, and including myself. It's like, oh man, we have to be able to do this. These are too good to not. And so a lot of motivation there, and that's the thing. If people want to do this themselves, it's basically, it's like, so yeah, you probably actually can do this.
Well, yeah. I mean, if the SMI thing is somewhat freely available, like
Oh
I
yeah,
could load up the SMI thing right now and tweak the Quadro that I have. So anybody really could do this at home. There's nothing like secret or kind of like crazy special about it, right?
no, I mean, this is yeah, this is it's no problem.
Yeah.
um let's see. Oh boy, here's a script that I did to do this. Okay, this is my whole testing script. But you can see how easy it is. I guess, yeah, you can see my pointer,
Mhm.
right?
Yeah.
Um, yeah, I'm firing up NVIDIA containers from NGC from
Mhm.
NVIDIA for TensorFlow to do the testing. So that's what this en route stuff is about.
Right.
And then oh, there's a typo here in this post.
Uh-oh.
I I just saw that. Uh, CUDA visible devices is just that's explicitly saying which GPUs I want to look at.
Mhm.
So I looked at different combinations of GPUs. So you can specify that here in an environment variable for this CUDA variable, and then um, what I did here, this command is this is the NVIDIA SMI.
Mhm.
This has to be run as root. So I use sudo. This is Ubuntu 2004.
Okay.
And this PM is persistence mode. And so what this command right here, this is not on by default. So this command right here sets the driver so that the driver does not unload kernel modules if there's no
Okay.
clients accessing the modules. If you're firing up like a CUDA job or something on a machine, just kind of by default. If you're running on a machine where that driver is not like firing up a display or anything like that, then it's not even loaded. It's not loaded until there's a demand for it, and then it loads as a module. Okay, and so that module can potentially unload also.
Okay.
Okay, so the persistence mode is and this is a Linux only feature.
Okay.
But I'm not sure how, like on Windows this wouldn't be an issue because Windows is always going to be accessing that driver because you've got a display going.
Sure.
Okay, so it shouldn't be unloading that module anyway. But so we have persistence mode. The driver is going to stay loaded, so that there isn't a chance of our other settings being reset because the kernel module is reloaded.
Okay.
Okay, for whatever any reason. So I set that, and then I explicitly set it to the available GPUs. They start from 0, and there's 4. There's 0, 1, 2, 3. That's why this 4 is bogus up here.
Oops.
Yeah. But then the next thing, what I did is I looped. I ran a loop, and I did a ResNet TensorFlow training job.
Mhm.
With synthetic data. That's the thing I normally use for benchmarking TensorFlow with TensorFlow. And I ran power from 100 watts up to 350 watts in 10-watt increments.
Okay, got it.
And I did this while I had the system running with 2 power supplies.
Okay.
Okay, so I had one power supply driving 1 card, and the rest of it was on the 1600 watt EVGA that we use.
Okay.
Which is a great power supply.
Mhm.
But 3 is the limit for that. If you tried to run that with 4 GPUs on there, then by the time when you hit 100% load on 4 GPUs with that, it's an overcurrent condition for the power supply, and the power supply shuts the machine down.
Oh,
It
wow.
reboots the system. That's a great power supply. It protects your
Yeah.
circuit.
Yeah.
Okay.
That's cool.
Yeah. So the power supply is a good high quality power supply is critical for anybody that's considering doing this, because you want to protect your circuit, you want to protect your board, you want to protect everything. So and
Yeah.
the power supply is your first line of defense for that. But anyway, so ran it all the way up to 350 with 2 power supplies on there, and then to set that limit, I just took that variable W and I just set this -PL with NVIDIA SMI
Mhm.
is power limit.
Makes
So I
sense.
just set it to that, and I set it for all those GPUs, whatever I was using the testing, and then I just fired up I used nroot to fire up the container and ran multi GPU TensorFlow job. Okay, and then just collected all the data.
Yeah.
And this is the little thing I want. Okay. This command right here trims out the information I need out of the output file.
Okay.
And I need that for the post that I'm working on today, which is how to automate all this stuff so it automatically happens as a service when you start up your system.
Oh,
You don't
okay.
have to do any of this. It just automatically starts it up. But I wanted to put some protection stuff in there. That's the only reason I haven't put the post on it. This is the thing I wanted to look for. Because like, oh, how did they do that?
Nice.
I got all this cut and sort. And, yeah, it's crazy. But anyway, yeah, so I collected that data, MaxQ data, and okay, here's a little details about those 2 commands that I used. Only 2 commands. This was all it was needed. The first one is setting that persistence mode. There's a long form for that and a short form. So this was obvious what it's doing. Persistence mode equals 1. Like,
Yeah. PM is
that.
yes, right.
And you do this, and it gives you feedback. And in fact, if you don't put that -I, that -I is a way to specify the item that you're looking at, the GPU that you're looking at.
Oh, okay.
And but if you leave that off, this will do all of them that are in the system. Okay, so this should set if you have 3 cards or 4 cards or 8 cards or whatever, it should do all of them. generally kind of like to be explicit about stuff like that.
Yeah.
But that's okay.
It's good practice.
Yeah. And okay, and then here's that power limit command. And again, the long form here is very obvious what it's doing. Power limit equals 280.
Right.
So that's the command for doing that. And you can set this stuff up, and then at idle, it's not going to be drawing that much power. In fact, these things are actually going to be idle in closer to, oh man, like 30 watts or something like that.
Right.
I mean, they'll be way down. Maybe no. They idle at 100 watts. These things
That makes
idle
sense.
hot. They
Sure.
idle with a pretty good current draw.
Hmm.
A little bit high, but these GPU these cards need quite a bit of power into them. Okay, just to do anything. And
Sure.
I hit that in an interesting way when I was testing. But anyway, so that's all it takes to do that. That limits your power. And then okay, and then here's another little NVIDIA SMI command. The Q is query, and D is like kind of like device driver, whatever.
Sure.
And there's all the things that you could want to look at for about the GPU is in here.
Oh.
If you just do that -Q and a card, it's going to give you all the information about a card.
Like fan speeds, temperature.
Yeah, all the settings as they're set, and all the things that could be set.
Frequencies and stuff.
Big dump of the
Wow.
information.
That's cool.
But this is what I use to monitor power, just to see actually how the thing was going. So I do that in a way. So I've got the Q, and I'm setting it to just pull the power information.
Sure.
And this example right here, I'm looking at that -I. I'm looking at one card.
Mm-hmm.
Okay, so that's the -I0, and then this -L is it's looping.
Oh, okay.
Oh, and one means loop for every 1 second. So this is, and then I filter, because that gives me min, max, and a bunch of stuff. I just want the one line that says power draw.
Okay.
So that's why I have this grep here, just to filter that out. So this thing just spews out the power from that GPU, the power load on that GPU as it's running a job. So I can monitor. I could monitor all four at once and whatever. But that's really handy if you're messing with this, experimenting. Yeah. It's like, okay, this is what's going on. You can see it easily. Now, fun stuff.
Yeah, the data.
What happened? How did it go? What happened when I ran that script? Let's see, what's all this nonsense here? Oh, this is I fit this to a curve just so I could match it. So I had a good curve fit to the data points. You could actually compute this max. You could look for where the slope of the line drops below 1 or something like that, or where it's rolling off to being less efficient. But this curve that I fit is not perfect, because it actually starts to drop off towards the end here, and really it should just kind of keep going and just level out.
Yeah.
But my curve, you'll see it starts to curve down a little bit. So it's not really the right fit exactly for the data, but it's a good fit.
Yeah.
But here's the first test right here. And so I decided to put all this stuff, multiple tests on a single graph, because then you've got a bucket load of information in here.
Right.
So I did this. I ran that test. I ran that script, looking at the power increases. And I did this with 1, 2, 3, and 4 GPUs. And then on all of these curves for each of those things, I just put a line in here where 95% of the peak performance was hit.
Okay.
And so you can see that line hits you right in here between that 275 and 300 watts. And 275, 270 even is really close to 95%. And this is like pretty much everywhere.
Yeah, I noticed that.
So you can hit, so that's kind of a sweet spot right there.
Wow.
That's a pretty reasonable power draw, and I kind of like the 280 because 280 I'm basically over 95% on everything that I looked at,
Yeah.
and
And still very
that
reasonable.
gives you and that's a big drop down from that 350 watts,
Yeah.
right? So and you still got most of the performance out of the cards. The another thing that you can see from this graph is the multi GPU scaling of
Oh,
this ResNet 50 TensorFlow job. The the performance, this distance between these lines, right?
yeah.
You can see how even that is.
Right.
That means the scaling is like every time I added a GPU, it this performance went up that much. So
Right.
I didn't really lose performance because of the multi GPU scaling.
Yeah. That's
Okay.
great.
So this is why you like people really want to have 4 of these GPUs in here
Yeah.
because you get a lot more performance,
Oh, yeah.
right? And if you look over here at the side, these are the actual images per second of that TensorFlow job. Um, and this is crazy good. Okay. This is really, really nice. Uh, that's a lot of performance. So there's compelling reasons. So I've had some conversations with some people that are pretty excited about doing this, and it's because they're going, oh man, yeah, this will take the stuff that I'm trying to work on, these models that I'm trying to fit, will bring it down from 2 or 3 weeks of running a model, training a model down to a few days maybe,
That's amazing.
right? So that's a huge thing. So
Yeah.
it's very nice. There's reasons that people are excited. Um, but so this I love these charts, man. I mean, this is just great information. But you can something I'll point this out because um, but you can see that it just follows a nice curve up.
Hmm.
If I spread that out, you would be able to see it. If I just put one on there, and you would see that it goes up really steeply and then starts to curve off. But
Okay.
because I've just got a really small range here for how this looks, it doesn't look like that's so dramatic,
Right.
right? If that makes sense. But something I'll point out here is that I threw the data out before I hit 180 watts,
Oh,
and that's because, well, let's see. Let me pop down to another one here. Okay, this is doing that same thing, but I used FP16, so I used tensor cores
okay.
for the job, and look at the performance up here.
Yeah.
It's insane. That's insane. Yeah,
And now
we're
that's way more dramatic on the four GPU line is like
oh
that's
yeah,
pretty.
yeah, and and the the tensor core performance, the FP 16 performance on these GPUs is fantastic. I had some trouble with that with the very first testing I did on these things when they came out. And it's like, oh man, the drivers are not quite right, the libraries are not caught up. But when I did this testing, the performance was really outstanding. It's
Yeah.
really good. So so this is a massively high. This is really a high number for that training run. Um, but you can see something here. Well, that one doesn't even show it that much. Well, no, I guess it's okay.
Hmm.
But you can see some of the kind of irregularities
Yeah.
in the training down here in the low power. Uh, what would happen is I would start this thing off at like 100 watts,
Mhm.
and I would get a performance pretty pitiful, right?
Sure.
But it
That
would
makes
work
sense.
right. But as I was bumping these up in 10-watt increments, for those first few trials, for those first few lines, it would start the job up, and then it would bump the power up. It would not honor the limit. Okay. And I
Huh.
don't know why that was, because it always honored it on the first the first shot through there.
Yeah.
But it was like, okay, it's trying to actually run the job that I'm asking it to do, and
Sure.
there's simply not enough power available to run the GPU and the memory properly.
Huh.
I mean, that's kind of what it seemed like.
Wow.
So it was like, oh, the GPU's going, I'm going to crash because I don't have enough power to run this job.
Well, that's interesting.
That's what it seemed like. That's kind of what it felt like to me. And so I would get these things where it would bump up. It would never exceeded the limit that I set.
Hmm.
Well, okay, that doesn't sound right. Um, it was funny behavior. It was funny behavior. It it um, it didn't go all the way up to like max limit, but it went up higher than what I had set it at,
Hmm.
and it was a little bit erratic of what it was doing in there. And I monitored the power. I looked at it, I was going, well, wait, this thing is doing more, drawing more power than I told it could use,
Yeah.
which was a little disturbing. Okay, so that's a caveat here.
Hmm.
However, by the time I got up to around 170 watts, it was leveling out. It was behaving, the way that it
Consistently.
should.
Yeah.
Okay. Um, this doesn't surprise me too much. It was a little bit like, but the behavior, at the higher power limits was completely smooth. I mean, it was exactly, it behaved well.
Yeah.
And I monitored power use, and it didn't, really go over. You get some performance variations,
Hmm.
just kind of natural when you run these jobs for whatever reason. Okay, so there you expect to see some kind of anomalies in there. It's not always going to be just a perfectly smooth line.
Okay.
Um, but anyway, that's something I kind of wanted to point out. Um, the But okay, of course, I looked at scaling, right? So I wanted to do an Amdahl's law plot, okay, which is what you do for parallel scaling. You usually use that on CPUs, but GPUs too. Um, and that's a line. This is basically kind of giving you an idea of the efficiency, the parallel efficiency, and it's basically saying that by the time if this is like 95%, then by the time you got out to 20 GPUs, you're probably not going to be getting performance improvement anymore because this line starts to drop off away.
Oh,
This would be if it was perfect scaling,
sure.
but after a time, you always lose something because you lose performance for communication,
Hmm.
um, and a few little other things. There's mostly communication, and just parts of the job that are not parallel. So eventually, if you have even infinite number of processors, there's a limit to how much you can get because at some point the non-parallel part takes over. You're
Sure.
limited by that. So that's basically saying that by the time you got out here to 20 GPUs or so, you're probably not going to be getting much gain.
Oh.
That's just on this particular setup with this particular job and
And like
what. There's
that's
other ways to do this though.
okay, because that sounds somewhat like theoretical. Where could you stuff 20 3090s?
Oh, you could have it in a cluster. You could have
Oh,
20,000
oh,
of them.
oh, snap.
Yeah,
Okay,
and in
okay.
fact, that's they do that. Okay, for
Aha.
training these big models, but but it's handled in a little bit differently than just the simplistic thing that I'm looking at here.
Okay.
Okay, but this is I wanted to do this because I just wanted to see, yeah, the scaling for multi GPU here is just outstanding. It's really excellent, and also I just wanted to show that the difference between that scaling at 350 watts versus that scaling at 280 watts is like, yeah, you're not losing anything in
Hmm.
the scaling by limiting that power. So it's really good.
Yeah.
Performance was really, really good. And this plot I really like because this one shows a lot of this is 4 GPUs here, okay, and this is tensor cores. This is FP16,
Mhm.
and this is showing that curve of that performance per wattage. And this time I'm reporting the total wattage at the wall.
Right.
So this was actually with 2 power supplies, and they were both hooked up into kilowatts,
Hmm.
these little power meters. and I just monitored them and just looked at the total power draw that I was getting from these two power supplies while the jobs were running. And so here, this gives you an idea, and this is that 95% mark
Right.
again up here. Um, and this is for this job with the 4 GPUs, 275 watts was at 96% of the performance, and that is a power draw of, it was around 1330 watts, something like that.
Okay.
And that's not bad. That's the total system power draw. And
Yeah.
this was a Xeon, a 24 core Xeon in there
Mhm.
with 384 gigabytes of memory in it. Okay, so this was a beefy platform.
Yeah.
Um,
Wow.
so the base system was drawing significant power too. But this is pretty reasonable. You could run this. You could run this. You could do this at home.
Mhm.
um, so that was really, really nice. This was fantastic to see. I kind of thought that the performance level was going to be down here. I was going to be happy if I saw like 85% of the performance.
Yeah.
Honestly, that was kind of my expectation.
Wow.
But man, to be over 95% at a reasonable power draw at the wall total for the system, that's not bad. So I'm, as far as I'm concerned, this is okay to do if you are like really know what you're doing and you understand like what's going on, and it's all really good components and da 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 da, right?
Right.
So yeah, this one's great. Yeah, 300 watts with 98%.
That's
So
really cool.
dropping, if and Houston, we were talking about this before we went live. Houston and I were talking, and we were talking about um, hey, if somebody that's just has one GPU, maybe
Mhm.
they want to lower the power load on their system and stuff like that. It's like, yeah, you could limit your power draw down to 300 watts on these things, and you're hardly losing anything.
Yeah.
That's for compute.
Right. Yeah.
Here,
That's
I should do these caveats.
yeah.
Okay, I'm not sure if
That's
I put them
important.
all in here, um, but there's definite caveats. My testing. This was Ubuntu 2004 server. I
Okay.
had no GUI on here.
Mhm.
Okay, I'm not running a display. I didn't even need to have monitors hooked up. I was just secure shelled into this thing and did my work. And if I was doing this and recommending it to somebody to set up a system to do it this way, that's what I would say. It's like, hey, do this as a headless server and just connect to it and do your work with it. Don't think that this is like your cool new desktop system,
Right.
although it really would be a cool new desktop system, right?
Right.
Um, but that would be the way to do it. Actually, and another thing you could do, and you can do this with NVIDIA SMI, is you can turn off the display capability for the GPU,
Hmm.
and that would actually lower your power consumption too. So if doing this in a server setup without using display on the GPU, you could actually disable that on the card, and that would reduce the load. In fact, I have a feeling that that aspect of the cards actually probably has a fairly high power draw, because if you look at the A100 compute card,
Mhm.
the PCIe card, which we'll be getting soon, and I'm just like dying to try the thing. It's a 250-watt card,
Right.
but there's no display on there. There's no display. There's no fan on it either. Okay, this is passive
That's
cool.
big.
It's a server card.
Right.
Um, but that's their big heavyweight, serious compute GPU, right?
Right.
And they're running it at a reasonably low power. Um, so that's another thing you could do. If you were doing this as a server setup, you could disable that 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 needless graphical interface stuff,
Gross.
right?
No need for that.
And kind of optimize your performance there too. You might even be able to knock this thing down even more for power and still have that real nice performance.
It'll be interesting to see. So I'm guessing for these tests and stuff, you didn't disable the graphic output part.
No, I didn't. I left
So
it.
I'd be very curious to see the comparison of 4 of these with their graphics turned off, running at 250 watts, which is 93% performance, compared to the A100. Because that's almost like apples to apples, right? At that point.
Kind of.
Okay.
I have to try this stuff because they're really pretty different GPUs.
Oh, okay.
The A100, this is an A102, a GA102
Okay.
is the actual GPU chip that's on these
Mm.
cards. The 3070 is a GA 103, so
Oh,
it's even different again.
wow.
Um, and the compute cards are A100.
Oh,
Okay, and
sure.
those cards, that stuff has been out for a while. That's the heavy duty compute
Mm.
GPU.
Okay.
But yeah, I'm curious too. The thing is, and there's more cards coming out. Okay,
Hmm.
now this is a consumer card.
Right.
This is that 30. It's a crazy consumer card. So 24 gigabytes of memory and just great performance, right? So yeah, a lot of the machine learning people are going to be really going to want to use these cards. I mean,
Yeah.
and NVIDIA, they don't always like that, but it's the reason they are where they are today is
Sure.
because people did that way many years ago, including myself. So that's the reason they're in the position they are right now.
Right.
So and people will still want to do this. But yeah, this was my first chance to really do kind of interesting testing on this, and I barely did any testing, right?
Mm.
I mean, I just ran this TensorFlow job doing this stuff. I had the machine for most of a week, um, and there was a lot of stuff that I had to run a lot. So I've got a machine booted up as today. Again, I've got access to at least that same platform, but with one 3090 in it.
Mm.
And I need that for the post that I was actually trying to put up today, which won't go up today. I'm sorry.
That's all right.
Um, but yeah, I kind of sidetracked there. The thing that I was going to bring up that yeah, this is actually, somebody might want to consider doing this for even with just one GPU.
Mhm.
You could do your power limiting and maybe have just a little bit nicer experience with the your setup with one GPU and not be hurting your performance. Um, but yeah, geez, that's good stuff.
Mm.
The post now this was the experiment to
Right.
show that hey, yeah, you can do this, and this is how it is. It's like wow, okay. The next post is and it's basically done. I've got the details in there, but I'm putting in more. I want to add some sanity checks
Mhm.
and some protection stuff into the scripts that I'm putting in this post. So what's going in that post is how to make this happen at boot time. So you start your machine up and this stuff is set, ready to go.
Ah, okay.
Okay, and so you've got persistence mode. It shouldn't unload the stuff. The power is going to be limited on the GPUs. This happens at boot. You start the machine, boom.
Mhm.
So that means just putting basically those two little commands into a shell script, and then using that as a service that I start with systemd. So I get systemd is the initialization service manager. Um, it's something that happened in Linux a couple of years ago that people just hated and hated and hated, but we really needed it, and systemd is here to stay. Um, but that's what starts up services and stuff like that when you hit the power button. That's
Okay.
systemd is starting up services. So I put it. So I've got in here a unit file, what they call a unit file, a service unit file, so that systemd at the right appropriate time will set the power limits on those GPUs during the boot.
Cool.
Okay.
Yeah.
Um, so that so that makes this actually like, yeah, okay, if you're going to do this for real, that's like, yeah, you just put this in there and you can fire it up and you're good to go. The but I want to, and I have it done. I've got the unit file, and I've got a script, but I want to put some things in there for some sanity checks on like setting that power limit.
Hmm.
I want to make sure that people don't try to set a power limit. Because you put this in the script itself. You can put it in the configuration, what power you want to set it to. But I want to be sure the scripts that I publish have a sanity check to make sure that they're not setting it to something that's higher than the maximum
Oh, sure.
power for the GPU. It won't go beyond that anyway, because you can't really change that.
Okay.
But I just want to put some sanity checks in like that. So this probably won't go up until Monday afternoon.
That's okay.
But I'm doing it in a good way. I'm putting it in user local, so it's a same place. Yeah, and I thought about something
Hmm.
when I was thinking about the stream. Um, you know, I did that the machine learning development
Hmm.
stack
Right. Right.
I did. That's actually perfect for this because that whole thing is set up to run without a display,
Oh, yeah. Yeah.
right? I mean,
Right.
I've got that stuff up on GitHub. It's all there. I haven't been back to it for like a couple months, and I need to do work on it. Need to do another iteration, and I need to update Jupyter Hub on there to version. I was waiting for that for a longest time, and then we got just super busy, so I haven't been back to it. But the idea there is I use a application called Cockpit, which is a remote web browser-based management interface,
Hmm.
server management interface. So use that. So you fire up a browser, you fire up Cockpit, you connect to the machine, and now you can do all the things like create users and add users and do all the kind of stuff you want to do on there. And
Right.
then I also have Jupyter Hub for launching up Jupyter Notebooks, which is kind of a typical way for people to do the machine learning work. And so all of that runs from the browser. So this would be a nice setup to have, with the 4 GPUs. This stuff is all booting up without a GUI. You've got these great GPU. Yeah, but this is another thing that you could do if you were setting up a rig for doing this. You could use
Right.
a stack like this, the machine learning development server stack that I put together, or somebody else put together too. There's others. But yeah, gee, let's get that out there. Well, we did a lot of talking on that.
Yeah. If you don't mind, maybe going a little past the hour, there were quite a few questions coming through.
Yeah, I'm not even seeing them.
So
Oh, for crying out loud. Oh,
we're
I'm on
gonna.
the wrong thing. Oh,
Oh,
there's the questions. Oh, right. Oh,
looking at our private.
sorry, everybody. I didn't even see it.
No, that's all
What
right.
is it?
So some sec, I believe, is how that's said on YouTube. He had quite a few questions. So we'll start with the first one that I recall is here. Does the power limit throttle the compute frequency or the memory bandwidth or both?
It doesn't mess with it, which is nice. You can those are parameters that you can also change, and yeah. Oh, okay. That's a really good question. But keep in mind that all of that stuff is dynamic.
Sure.
Okay,
Because you'll get boost clocks and things like that.
it's complicated. Those clocks and stuff like that, they ramp up and down,
Mhm.
almost instantaneously ramp up and down, depending on the load that's on the system. So the answer to that is yes. Yeah,
Okay.
you're not going to be getting 100% performance.
Right.
So you're probably not hitting all the way up to the maximum clock frequencies. And there's several clocks too.
Right.
Okay. So only thing we're doing is capping the max power limit.
Oh,
So
sure.
how that is distributed dynamically across like the memory clocks, the SM clock, the it's complicated, but that's still all just going on automatically on the GPU from what it would normally do.
Okay. That's
But yeah, there's a trade-off, and I did not monitor that. I did not look at it, but I did think about it. So
mhm.
that's a great question. Um, the
Man. There's a
and the loads that I was running, I was not. I really didn't have any. This Resonant 50 with synthetic data. I'm not loading any. I'm not stressing the communication over the PCI bus or anything like that.
mhm.
So I don't know. So those are unanswered questions. My feeling is that given the overall performance, I don't care.
Sure, sure.
Because it's going to drop something. It's going to have to compromise somewhere because it's not getting full power.
Right.
Um, but the thing is that happens so dynamically and so quickly that if there's all of a sudden demand on the memory bus, okay, then that's where the power is going to go.
Oh,
Okay, and the SM cores are going to be. I mean, that stuff is going to be idling, waiting on data transfer anyway.
hmm.
So power management on modern stuff is just insane. But it's
Okay.
really, 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 really good. So I wouldn't worry about that too much. But that's a great question.
Yeah. Then had another question as well from Sumsec. Does the GPU TDP include full shader tensor RT memory? If so, there is a lot of room for lowering power with equals perf if one is only using
Yes,
shaders in memory.
yes, exactly. I was kind of mentioning that earlier. You can you can set. There's a bunch of parameters you can set with NVIDIA SMI, and it's absolutely worth experimenting with. Yeah, you can set the performance level, and you can set and like I said, you can basically disable the the display parts of the card, right? So you can do that. So there's a lot of experimentation that can be done. I think basically the testing that I did kind of set a baseline
hmm
for like the simplest thing that you could look at and do, and it worked. It was good.
That's so
There
cool.
is there room for improvement? Yeah, I think there's plenty of room for improvement. Um, and the thing is, I would not discourage anyone from trying some of this stuff out
Yeah.
and seeing what you can do, because you can probably get better performance, or maybe even better, to drop that power load down even more. Um, I wouldn't be surprised if you can get that power envelope down closer to 250 watts and still be having really, really nice performance.
Hey.
I'm just guessing, but
Which I
yeah,
mean, it makes sense if they're able to do that with the A100. The
yeah, I
250
really got
watt
to check this out
seems,
because, man, I haven't fired this up. I don't know.
yeah, that'll be cool
I
to see.
I know the big modules, the SMX modules. Somebody was saying that those things have like a max power draw of like 400 watts or something,
Whoa.
which is crazy high. So I'm like, wait a minute, wait a minute, wait a minute. Um, there's, but yeah, yeah, the thing, I keep saying this, but it's really, really true. All this stuff is very, very complicated. It's very, very dynamic.
Right.
Um, um, but it's also insanely fantastic. The performance is just, I've been doing scientific computer. I've been doing pushing things to the limit for a long, 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 long time. And man, I think back to my research, like when I was a graduate student. It's like, oh my God, I would have been happy to have the performance I get on my cell phone. So, so yeah, but yeah, man. Hey, and if you get some really cool stuff, I appreciate it when you pop up interesting stuff and we throw it into a comment on the post, because I like to see it. if you've had any trouble, I definitely want to know about it. If you've had success, I want to know about that too, because that's really valuable information to me, and I honestly do appreciate that kind of feedback, and I think it's great to have it out there in the public. So either do a post yourself, put it up somewhere, or but I really appreciate it when you throw interesting stuff, testing and stuff like that onto a comment on one of the blog posts, because I think it helps the entire community in a
Oh
big
yeah,
way.
it's good
Big
to
way.
add
So
to the conversation. Yeah.
yeah. I love it when people do that. I've gotten some great ideas from stuff that people have posted and comments. I'm going, oh man, I didn't even know that. I got to try it.
That's great.
So yeah, it's awesome. Thank you.
There was a mention as well. Oh, also from SumSec again. Could you please comment, i.e., drool, about the new DGX Station A100 system that NVIDIA says only uses 1500 watts?
Wow. Oh, I haven't seen that. I haven't seen that spec. Oh yeah. Oh yeah. Drool. Hey, I will tell you. Okay, I'm the guy at Puget Systems, right? And uh, I am all in favor, and I'm good. Starting in the new year, I'm going to try to put a little bit of. We'll see how it goes, but I would like to be on the DGX provider list.
Ooh.
Okay, because I don't think those things are priced insanely bad. I mean, they're high, they're beautiful, and that new that new DGX workstation is insane. That's just insane. I mean, I've seen the others, up. I've had my hands on them.
Mhm.
They're It's a really really beautiful build. They did great design work on that. Really great. They are not cheap. That stuff is not cheap. Okay,
Right.
but it's pretty darn good. And I I'm really curious to look further into that, and I would love to see us actually offering the DGX
That'd be
stuff.
cool.
I think we could, and I think it kind of fits with kind of some of the stuff that we want to do going forward.
Mhm.
Um, maybe not, it's kind of not really the kind of thing that we would historically do, because we
Sure.
want to do our own kind of stuff and do that. But I like that. I like that box. I think it was great. The thing that was just crazy on there is the way they did the cooling,
Oh,
sub ambient cooling,
okay.
and
Wow.
what that means. Okay, it's fluid cooled,
Okay.
but it's refrigerated in a sense. Okay, that thing has a compressor on it.
Oh,
Okay,
wow.
yeah,
It's a
yeah,
mini
this is cool.
fridge?
That's what sub ambient means.
Yeah.
Um, they're cooling the radiators are cooling below the outside ambient temperature.
Okay.
So it's working like a refrigerator would work.
Right.
So it's doing a compression expansion cooling. This is thermodynamics 101 here,
Yeah.
okay? And so they're cooling the radiator that coolant is moving through. So it's dropping it's pulling the temperature down below the ambient temperature.
Nice.
Now, you also cannot violate thermodynamics.
Well, yeah, that heat's
Okay,
gotta go somewhere, right?
the heat has got to go somewhere, so you still have to get rid of all that heat.
Mhm.
Um, and in fact, you are actually lowering your efficiency a little bit by adding that compressor in there. Well, that's highly efficient. Refrigerators are insanely efficient
Right.
with the power,
Love
the
it.
power usage and the cooling you get out of it. But that is so cool.
Yeah. I can just
Yeah, I love it. I totally hear you on that one. That one is really, really cool.
I can
Um,
just imagine, like, the prototype for that was just, like, a mini fridge from Home Depot and a bunch of graphics cards stuffed into it.
oh, you know, there does, if you look back at what they did when some of that first hardware they did, the digits box that they did,
Mhm.
I did not like that thing. Okay. I didn't like the way they designed it, but it was cool.
Yeah.
It was nice that they did it. And it opened everything up for everybody. It's like, heck, everybody followed, all their partners followed, and it was really, really a great thing. The stuff that they've done in the last couple of years, the DGX stuff, is very, very custom, and they pulled the stops out on the design, and they're just really beautiful to look at. That gold anodized aluminum chassis and the grill work and stuff like that, it's really, really pretty. It's really nice looking. And yeah, that I'm sure that thing is just, really serious. The thing is, man, you're going to be able to get really close to the kind of performance you're going to want out of that
Oh,
on
bet.
like even with like 4 of these 3090s in there. I was going to bring that. I just really quickly,
Mhm.
other GPUs. I started to say that um, the A40 and the A6000
Mhm.
are coming up. Okay,
Mhm.
and I'm finally getting to test on the A100s. Okay,
Oh, right.
so we're gonna be offering those in some of our rack gear, and but it got me thinking. And those, I'm super anxious to try the A100. There's so many amazing features on those GPUs. But the A40 is the passive cooled, um, like the A6000 is what the Quadro. They've dropped those
The
brandings.
Quadro name, yeah.
But this is the Quadro. So the A6000 is active cooled. It's essentially the Quadro line.
Sure.
Okay. Um, I'm not sure. That's probably the GA 102 chip that's in there,
Hmm.
but the firmware is different. So it's configured different. So it's not going to be like the RTX cards.
Okay.
Um, and they've got some really interesting features, like the GPU virtualization and stuff like that, which is probably essentially doing the same thing as the multi-instant GPU on the A100, which I'm
Hmm.
really curious to try. That's partitioning the GPU. Um, um, but uh, that the A40 could make a really, really sweet machine learning server.
Oh.
That may actually be a pretty nice alternative to doing the A100s, because you don't really, for a lot of the stuff for the machine learning, the training work, and inference work, you don't really need the double precision and all the just
Hmm.
insanely great stuff that's on the A100. What you really need is the FP32 and the TF32, which I haven't tried. There's a bunch of really great new stuff in on these GPUs, um, and so that may be pretty sweet too. So I definitely, keep an eye out for that stuff, because that could be cool.
Yeah.
Um, I could go off on a million tangents here, man.
There was another question kind of earlier on, Robert
Yeah,
Gibson
sorry.
on YouTube. He asked, have you tried an equivalent Windows system build using the MSI Afterburner utility to set the max power? And so I
Oh,
kind of want to tweak that a little bit too. You had mentioned that the SMI thing is available on Windows. It
it
gets
is.
installed as part of the driver. How would or where would somebody go to look if they wanted to play around with this on a Windows machine?
It is in like Microsoft, like Windows System x86,
So
NVIDIA,
there's like an
something like
executable
if you
somewhere.
search, just search on your Windows machine, do a search for NVIDIA SMI, um, and you'll find it.
Okay.
It'll pop up, and it's there, and it's the same utility. It's the system management interface.
Mhm.
Uh, I have not tried this yet on Windows,
Okay.
but I'm really glad you asked that, because I definitely wanted to mention that. Um, okay, I have not tried it yet, but I don't see any reason why it shouldn't work just fine.
Sure.
Okay, um, it seems a little bit out of the uses that you might want to do for a Windows box, but why not?
Yeah.
You can do this stuff on Windows. You can do it. I mean, the platform of choice is definitely Linux for this stuff, especially the heavier you go with it, right?
Mhm.
Um, but I've helped a lot of people doing Windows stuff, especially in the machine learning, and I feel really, really good about that. That a lot of people are doing the stuff that maybe would not have done it. So, um, so I think this is a go for Windows.
Cool.
I will actually try to do that myself. Um, you, we can see, we can see what happens. The persistence mode is not available on Windows, but I don't think it matters
Okay.
because I think as long as you've got your GUI, as long as you've got that graphical interface, that driver it's just going to stay loaded. So you don't
Right.
have to worry about any kind of module dumping or anything like that.
That would, yeah, it would
I
make
don't think
sense.
that even matters. You should be able to just do this with doing the power limit setting, but you would have to do all of the serious testing to make sure that it was working right before you made any kind of a commitment to like an over the top box with a quad build, right?
Right, right.
I'll try to do it. I'll try to do it. I hope to
Cool.
answer that for you with some real numbers.
That'd be fun.
Yeah, it would be fun. It'd be cool.
I'd love it if you threw in some just like one little goofy game benchmark too while you I'm just I think that would be fun just as like a little Easter egg sort of
Oh, hey, that's the other thing. I've only tested Resonant 50 with TensorFlow
mhm.
on that quad thing, so I haven't really hammered on it. I haven't done proper multi GPU testing
Okay.
on the RTX 30 cards yet.
And that makes sense because this was really just more proof of concept. Like,
This is
can
proof
we
of
do
concept.
this?
Yeah,
And so now it's going to be looking at like, okay, let's try some real world stuff. Let's see what this really can do. Because like
yeah.
you had mentioned something about memory bandwidth through the PCI bus, or I
Oh, there's
might,
all kinds of considerations. Yeah.
uh, yeah. So this will be very. I'm for one very interested to see because you just get so excited about it, and I love just
Oh,
hearing
I
about
love it.
how cool this stuff is, and it's such an interesting and kind of almost mad scientist kind of thing to be doing because
Mhm.
yeah, I don't know, it's just fun.
Literally.
It is. It really, really neat. But can I feel like this is one of those things too where it's a big step. It's kind of a almost a breakthrough where like this might actually be something really cool and very applicable to everybody or
Yeah.
everybody in this space at least. Because yeah, I mean,
There's going to be a lot of people doing research and stuff like that that are just going to be thrilled.
yeah,
I was really happy to put this stuff up. It's like, here you go, guys, knock it out.
right, right,
I did. Yeah, I'm really happy to have been able to do that and kind of get the ball rolling on some, helping people get research systems set up and get them cranking.
yeah,
Um, I don't know if we're well, I know we're over, and maybe that's a good thing. Um,
a little
but
bit.
we are considering this as as an offering, but what we want to do is really we want to get Gigabyte to do firmware mods for us,
Mhm.
and then have essentially a custom um,
Card,
SKU of that blower card. And then that way, this just removes all of this software, all this messing around stuff from
right?
it, and it just becomes like totally like, okay, this is a power limited version of this card, that could be used in lower power builds or for multi GPU where power limiting is required. That's what I'm hoping.
With that shell script, is that really necessary? Because if you have it set up to start on boot, there's at least less of a concern of something bad happening during a job or right because it's going to be loaded as soon as the system turns on, and then by the time you start running your job or whatever, it should already be power limited that way.
Mhm.
Is this more just like a kind of foolproofing it or
It's
making it so
it's
that
foolproofing it.
you
Yeah,
don't have to fiddle. You just will send you a box and it's already just gonna work.
absolutely. It's just going to work. No matter
No setup.
whatever you do, that's the limit of the power on the GPUs. Go to it. Yeah, doing this in a configuration, starting up at boot, that's the way to do it. If you're, um,
If you're at
and
home.
and that's completely okay. But what if somebody is like doesn't really know? about that,
Hmm.
and they like reinstall the OS,
Oh,
right? Or what if,
right.
and then they go to try to fire this up, and then their machine's crashing because it's drawing too much power. Or what if something just really crazy goes wrong and this overloads the circuit. I'm not too worried because like a good power supply and good motherboard are just going to they're just going to kick out.
Right.
But you could trip breakers. you know um, I mean, I've tripped lots of power breakers in my day.
Oh, hey,
Okay, I
we've
mean lots.
I was in production. You put
Oh yeah, oh,
you get
we do it
4
down there.
GPU systems going for load testing, and it blew out. That's why we had to run a bunch of heavy duty lines into production.
Yeah, yeah, yeah. So
Somebody
so
turned.
but there's those little what ifs that for me as a researcher and a scientist, like yeah, who cares? We're in a lab, we're making our own equipment. We're making you know a tunneling microscope or whatever, and zapping things with lasers that we build ourselves, right?
Yeah.
So yeah, this is no problem. Um, but for a company like us, we have to be very, very, very responsible to our customers, and so if I'm no matter what my feelings are on it as a researcher and a scientist, I completely concur with the consensus of everyone in the company about whether we should do it or not.
Right.
Um, we would probably easily be able to say like, okay, we can do a 3 GPU system, and we can leave a slot open.
Right.
Wink, wink. Right?
Which we do. We do have triple GPU three not 33090 systems available.
Yeah, I got to get my configuration pages cleaned up. They're a mess. Talk to the sales guys if you want to do this because they know what's going on.
That'll be funny.
Uh,
Can I get a triple 3090 and an extra one on the side? Don't plug it in. Just
yeah,
send it.
don't put it in there. Yeah, but I do need that blower card. And by the way, can you wire the cable over there for me?
Yeah. So I might install a fourth one, but it's okay.
Yeah. Oh, and put a Ubuntu 2004 on there, and yeah, I'm ready to go on this. uh, yeah, honestly, I think it's totally doable. I think it's totally doable. But whether we can ship them out the door like that and say, and support the whole thing,
Right.
that's I do not want to open up a can of worms for all the folks here.
Well, I mean, it's all about that customer experience, right? We
Yeah,
don't want to
yeah,
send out a product that's going to end up even potentially causing a bad time,
yeah,
or
exactly.
and
Totally.
man, how bad would we feel if some monster job fails and you lose your grant or whatever because something we did or didn't.
Yeah, yeah, yeah. We're ultra conservative on stuff like that, and we've always been that way. And I concur with it. There's a reason that we don't do overclocking and stuff like that. We used to do a little bit, but it's like, no, we don't want to do that. We don't want to. We don't want to take things out of spec.
Right.
Okay. So that's kind of the bottom line here. But I felt like it was my obligation to my colleagues in the community to try this out and see if it would work right. So I'm really feeling good about that.
Yeah. So one last question though: are NV links available for the 3090?
Yes.
Okay.
And there are, but it's only between pairs.
Right.
Okay.
Right.
And that's how it was on the 20 series too.
Mm-hmm.
Um, and I did try it. I hooked a bridge up between two cards because we had a bridge,
Mm-hmm.
and but it didn't work. But I didn't have an opportunity to investigate it.
Ah.
But that was early. It could have been. I mean, I'll urge everybody to take a deep breath and relax and give yourself a chance for some of the dust to settle on all this stuff. The drivers are finally coming together. The optimized builds on NGC are coming together. The CUDA libraries are all coming together. So all of this stuff uh, it is happening, but it takes some time. And that first launch stuff was like, whoa, some stuff just didn't work. I mean, I had trouble with a lot of that stuff, and that was one of them. NVLink did not work when I tried it, and I have not had a chance to try it again. But that could have been, a fluke of having a faulty bridge.
Mm.
But I suspect it was more of an early driver problem that was just like really not functioning yet. It was just not. It was just not happening. But to answer the question, yeah, and it should be very, very good. And I had luck before, surprising, doing 2 pairs in a quad GPU setup.
Yeah. You have a
Ideally, you want to have multiple connections on each card so that they're all connected, right? But I had pretty good luck with 2 pairs, and the places where that comes in to be important are places where you have heavier GPU to GPU communication loads. And the benchmark that I ran where it showed up was an LSTM. So that has history in the model. So there's dependencies back across time. So basically, time series kind of loads and stuff like that. You're going to have more GPU to GPU communication. Those things are going to be more important. Where you have things like a lot of the convolution networks and stuff, you've got data parallel. So you just stream you get the data out onto the GPUs. They grind, and then they exchange data. They get more, and doing the mem copy back to CPU space for accumulating like gradients and stuff like that, it's not so bad. It's not so bad. And because the stuff is heavily buffered, it doesn't really make that much difference. PCI X16 versus X8, V3 versus V4, all those things have an effect, but not a massive effect. But my feeling is that the performance gains that I got before with NVLink totally justified the cost of the bridge. Okay, it's like when you need it, yeah, you're going to get that boost that's going to easily have paid for itself just by having the bridge. So yeah, I like those things. I think they're great, and I will definitely test.
Right on. Awesome. Well, that does put us a little bit past our time, but that's
Quite
okay.
a bit past.
This is really big stuff. So and I think it's
really
going to
fun.
make big waves in the scientific community. We could be having a lot of fun with this in the future. So I'm excited to see what you do.
Houston, everybody working on a plan going for 2021. Hopefully, up the game a little bit on some of the stuff we're offering, and some really great stuff is coming down the pipe. Okay.
Oh yeah.
Oh boy, some really, really nice stuff from AMD is looking sweet. A lot of cool things to test out, and I'm going to be busy. I'm doing stuff with Intel. Intel's got some great stuff going on. One API looks awesome. I'm gonna dig into there. All kinds of things. The cool stuff that we're doing, like in game dev with Unreal, and AI along in there with that. The machine learning stuff going along in there.
Yep.
It's going to be another insane year.
Oh yeah, it's big. Well, I mean, anytime we have these major, like this is from all angles, this has been a very significant hardware launch from CPUs, GPUs, everywhere.
Yeah.
So yeah, this next year is going to be big. It's going to be awesome.
Yeah, it's more of the same, man.
For sure.
More great stuff coming down the pipe. Jeez,
Yeah.
really excited about it.
Awesome. Well, thank you, Don, for taking time out of your day to get this explained and kind of give us a peek into the future of things. It's going to be really, really cool. And as always, thank you to the audience as well for joining us. We do this. This was a lot of fun. I always love. A lot of it is, whoosh, but it's still so cool to to know that we're really pushing the boundaries in this place is really cool. So yeah, thank you. Oh, and my normal outro, we do this every Wednesday and Friday. Wednesdays we bring industry experts on to talk about their workflow and give a little peek behind the curtain, tips, tricks, advice, and stuff like that. And then Fridays we have our labs open office hour like this. We bring in our experts to talk about what they do and the crossover of the software expertise and the hardware that they get to play with every day. So mark your calendars for that. Wednesdays, Thursdays, 1 p.m. Pacific. And I think that's it. We'll see y'all next time.
Sounds good. Bye, everybody. Thanks for stopping in.